You are watching video on SEE Class 10 Subject Science. In this video series, we are going to study chapters of Physics, Chemistry, Biology, Astronomy and Geology. Now this video deals with Physics chapter Force, and this is part 3 of the chapter. Now in this part, we are going to study relation of gravitation with its factors. We are going to see variation in gravitational force with the change in its factors. Now we'll see here first case. Newton's universal law of gravitation is represented by this formula. Here, F is gravitational force, G is universal gravitation constant, M1 mass of the first body, M2 mass of the second body, and D distance between the centers of the masses. Right. Now in this formula, mass changes but distance remains the same. What will happen to the gravitational force? In which way gravitational force will change when mass changes but distance remains the same? So what change will be there in the calculation of gravitational force when mass of the first body becomes 2m1 instead of m1, m2 remains same and D also remains same. So we are going to see it from calculation. We are going to do the calculation to see the changes in calculation of gravitational force. So here, when mass of the first body changes, it becomes 2m1 in place of m1 and m2 remains same, D remains same. So now let the new force be F1. When mass changes from m1 to 2m1, then calculation of gravitational force will be different from the previous one. Okay. Now let the new force be F1 after changing m1 to 2m1. So here m1 is changed to 2m1. In what way gravitational force will change? Okay, what will be the calculation? So here let the new force be F1. So here F1 is equal to G. In place of m1 we have to write 2m1 because this is the new mass, and m2 is remaining same and distance also remaining same, D square from formula. Or F1 is equal to, bring this two coefficient in front, 2 G m1 m2 divided by D square. Now or F1 equal to 2, here G m1 m2 divided by D square means F from equation number 1. Okay, so in place of this entire expression we can write F, because F means is equal to G m1 m2 divided by D square. Okay, so this is equal to this. That is why we can write F in place of G m1 m2 divided by D square. Or you can write from equation number 1. From equation number 1. From this equation also we can replace, substitute this value of F. Right. So here what we have found here is new force is equal to 2 times of previous force. 2 times of previous force. Okay, 2 times of previous force is equal to new force when the mass is changed from m1 to 2m1. Right. So you can write the final statement in this way. Your answer should be this way. Gravitational force increases by 2 times when mass of the one body is doubled, when m1 is made 2m1. So this is number 1. So you'll get the question in this way: what will happen to the gravitational force when mass of the first body is made double and distance between the centers remaining same? So this is the question. And question number 2. Now we'll see question number 2. In this case, this is the formula to represent Newton's universal law of gravitation, F equal to G m1 m2 divided by D square. Right. Now here in this formula, mass changes but distance between them remains same. What will happen to the gravitational force when mass of both the bodies changes, increases by 2 times, mass is doubled and distance between them remains constant? Distance is not changed. Mass of both the bodies has become 2m1 and 2m2. Okay, what changes will be seen in gravitational force? Yes, so now we are going to see this one. m1 has become 2m1 double m2 has become 2m2 double and distance is remaining same. Now let the new force be F1. When mass of both the bodies changes in this way, then there will be new gravitational force. This gravitational force will have new value. Okay, now let that new gravitational force be F1. Right, now we are going to see the calculation over here. F1 equal to G m1 m2 divided by d square. Here m1 has become 2, m2 has become 2, 2m2, 2m1 2m2 divided by d square. Okay, from formula d square. F1 is equal to 2m1, or you can write it this way, 2m1 2m2 divided by d square, right? So this is looking untidy. Now here do multiplication. 2 2s are 4, 2 into 2 4, and g m1 m2 divided by d square. Right, here F1 is equal to, you should write or here in front because this is equation. F1 equal to 4, and in place of g m1 m2 divided by d square you can write F, because from Newton's universal law of gravitation, F equal to g m1 m2 divided by d square, or you can write from equation number 1. From equation number 1. Okay, from this equation you can replace the value, substitute the value here. So F1 new force is equal to 4 times of previous force. Okay, so here answer you can write it this way: gravitational force between two bodies increases by 4 times when mass of both bodies is doubled. So this is the answer. You can get the question this way: what will happen to the gravitational force when mass of both the bodies is doubled, distance remaining same? So this is the answer. You know, new force, gravitational force increases by 4 times of the previous one, 4 times of the previous one when mass of both bodies is made doubled. So this is your number 2. Now we'll see number 3. Number 3, in this case what we have seen is number 3, here mass remains constant but distance between their centers is decreased by half. So this is the change condition. Now what we'll see here is mass is remaining constant, mass is not changed, m1 is remaining m1, m2 is remaining as m2, but distance has been made half d. Distance is decreased by half. So what will be the changes in gravitational force? Okay, now we are going to calculate new gravitational force. Now let the new force be F1. When distance is made half, then the gravitational force will have new value. Okay, new gravitational force, and let it be F1. Let it be F1. Okay, now we are going to see F1 is equal to g, mass is remaining same, m1 m2, but distance has been made half. Okay, and d square, from formula this square, or F1 is equal to g m1 m2 divided by half d square, means half is made square. Okay, you have to do square of this half. 1 into 1, 2 times, 1 into 1, 1, and 2 into 2, 4. 2 2s are 4. Okay, 1 by 4 d square, by squaring the whole. Okay, 1 by 4 d square, or you can write it this way: F1 is equal to 1 divided by 1 by 4. This 1 by 4 is in denominator, 1 by 4. Okay, and g m1 m2 divided by d square, right? Or further solving, or F1 is equal to 1, this is division sign, and when you make it multiplication, this fraction will get upside down. Okay, into 4 divided by 1, g m1 m2 divided by d square. Okay, now or F1 is equal to 4 into 1, 4 and 1 is there, g m1 m2 divided by d square. Okay, now here what can you do is, or f1 is equal to 4 g m1 m2 divided by d square. In place of this expression, in place of this expression, you can write f, because we know f equal to g m1 m2 divided by d square, right? Okay, so equal to sign should be here in the middle. So f is equal to g m1 m2 divided by d square. So in place of this you can write f over here, right? With this one. Okay, now here new force, f1 is new force is equal to 4 times of previous force, 4 times of previous force. Okay, when the distance is made half between their centers, distance is made half between their centers, right? So you can write answer statement in this way. Therefore, gravitational force increases by 4 times when distance is made half between their centers, right? This is the answer. So you'll get question this way: what will happen to the gravitational force when mass of both the bodies remains constant but distance between their centers is made half? Okay, decrease by half. So this is the answer. Now we'll see question number 4. Now question number 4 is, this is the formula to represent Newton's universal law of gravitation, F equal to g m1 m2 divided by d square. Okay, let this be question number 1. Here mass remains constant but distance increases by 2 times. Okay, here distance is increasing by 2 times. Okay, what will happen to the gravitational force, or what change will happen in the calculation of gravitational force? We are going to see that m1 is remaining m1, m2 is remaining as m2, no change. Distance has been made double to d. Now let the new force be f1. After we make distance double, then gravitational force will change in its calculation. Okay, so let this new force be f1. Now we'll see the calculation. f1 is equal to g m1 m2 divided by d square, but d has become 2d in this case, 2d square. Now or f1 is equal to g m1 m2 divided by 2 square means 2 into 2 times multiplication. Okay, so here 4d square, right? Now or f1 equal to this 4 means this is 1 divided by 4, it is in denominator. Okay, you can write it separately. So g m1 m2 divided by d square. Yes, now f1 is equal to, or f1 is equal to 1 by 4. Now you can write f in place of this expression. Okay, f, because f is equal to g m1 m2 divided by d square, or you can write from equation number 1, this one. Okay, you can write this also. So here what you have found is new force is equal to, is decreased by, okay, 1 by 4th of initial force, right? f1 is equal to 1 by 4 f, or you can write it this way, or f1 is equal to f divided by 4. Okay, because 1 into f is f divided by 4. So new force decreases by 1/4. New force decreases by 1/4 of initial one. Yes, so you can write answer this way: gravitational force between two bodies decreases by 1/4 when distance is made double or increased by 2 times. So you'll get the question this way: what will happen to the gravitational force when distance between the centers of two masses is made double? This is your answer. Now question number 5. Question number 5, it is this way: what will happen to the force between two bodies when mass of each is made doubled and the distance between them is tripled? Now from Newton's universal law of gravitation, you can write answer this way: F equal to g m1 m2 divided by d square. Here m1 is made 2m1, m2 is made 2m2, double. Okay, distance is made 3 times. Okay, distance is tripled, means 3 times. Yes, now let the new force be F1. After we make all these changes and the gravitational force will have new value. Okay, let this be F1. New gravitational force be F1. Now we'll see the calculation here. F1 is equal to G. M1 has become 2M1 and M2 has become 2M2. Right? And the distance has become 3D whole square. Okay, or F1 is equal to 2 into 2, 4. 4G M1 M2 divided by 3 square means 3 into 3, that is 9. 9D square. Okay, now we are going to separate coefficient here, or F1 equal to 4 divided by 9. 4 divided by 9G M1 M2 divided by D square. Okay, so or F1 is equal to 4 by 9, and we can write F in place of this entire expression, because F is equal to G M1 M2 divided by D square, or you can write from equation number 1 also, this one. Okay, you can make it equation number 1. Okay, so new force is equal to 4 by 9 of initial force, means decreases. This is the decrease. Okay, because denominator is bigger. Now here you can write answer this way: gravitational force between two bodies decreases by 4 by 9 times when mass of each body is doubled and distance is tripled. Distance between their centers is tripled. So this is the answer you can write. So here what we have found is when distance is increased, then gravitational force has become less. Okay, gravitational force decrease. When distance is increased, gravitational force become between two bodies decreases by 1/4 when distance is made double. Distance is made double, gravitational force is decreased. When distance increases, gravitational force decreases. Okay, so this proves the second condition, and the first one is here: when mass increases, then force also increases. Gravitational force between two bodies increases by 4 times when mass of both bodies is double. So this proves the first condition. No, when mass increases, force also increases, but when distance increases, force decreases. So this proves Newton's universal law of gravitation. With this we finish this part, and in next part we are going to do gravity.